All right, thank you very much. I'm from HOPR. We're a small startup from Switzerland. We're working on fixing not just Web3 privacy, but also Web2 privacy with something called HOPR. And so, for those of you who've never heard about HOPR, we're a decentralized network which preserves privacy and metadata privacy, most importantly. But speaking about network, it's it's not like a blockchain network. We're more like a computer network. So we're operating sort of like on layer 0, so to say. So just to give you an idea what problem we're trying to solve with HOPR, and that's a problem that you probably see every day while you're communicating with basically any other party, so being that an RPC provider, for example, or just a website or anything, you're making basically a direct connection to that destination server or something. And that means that whatever information you give them, with that they also get, for example, your IP address or your additional metadata. So for example, when you're talking to an RPC provider, when you're like making a MetaMask and transaction using MetaMask, the RPC provider knows your wallet address, of course, but as well it also knows your IP address, right? This brings a privacy problem because that means that your wallet could be linked to your IP address, and that means that basically your on-chain activity could therefore be linked to your off-chain activity. So if that provider is malicious, they could use your metadata to basically discover your trading activities, do an MEV or sorts of nasty stuff. So the way that HOPR is trying to tackle this problem is very similar to something called Tor, if you heard about it. You probably heard about Tor network, right? So as you know, there's like a set of nodes running in the internet run by individuals, and these are voluntarily running nodes, and these act as a relays. So basically, instead of communicating directly with your RPC provider or MetaMask, you communicate through a node, and that's pretty similar to what HOPR does, right? There's a bunch of nodes running in the internet, and the communication is relayed through the HOPR nodes before it reaches the intended destination, being that a server or an RPC provider. But what makes us really different from Tor, for example, or other mixed nets, is that we also, to this transport layer, bring up an additional so-called payment layer. So it's not just that the relayers are relaying the information for you, they're also getting rewarded for that fact that they're relaying information. So to say that if you want to have privacy, you basically pay the relayers to relay your information towards the destination. So basically, you have like two addresses. One is the transport layer address, we call that a HOPR address. And then you have like a payment layer address, and that's basically the wallet address of each node, right? So when HOPR communicates and sends messages over, you're also like issuing tickets for the relayers. And if the information is relayed to the destination, and you got to prove that the packet has reached the destination, you allow these relayers to redeem their rewards for sending that information over. And for that, we have an innovative or a novel addition to this. That's a proof of relay, basically. And that means that there's a cryptographic proof that the data you've sent and the node have relayed them. There's a cryptographic proof that they actually did it, that they did relay the information, and the destination has received it, and therefore they can redeem the tickets for their reward. There are some interesting details about how all this works and technical details in something we call the yellow paper. So there's all the cryptography that's involved in it. You can check that out. So most importantly, we'll be doing a short live demo here today, and that will be, well, we're going to set up a small local network on my computer. There's going to be consisting of a couple nodes, that all nodes will be connected and will be able to relay information basically between the nodes. You can also run it yourself, but given the fact that the Wi-Fi is not really excellent here, I would say, so will not be doing like a Git pod, which is like our main development setup that you might use. But I'll be like doing a local demo. But the difference is really negligible. The steps are pretty much the same. So you can go ahead and visit our monorepo on GitHub, which basically contains the entire source code of HOPR. You can use the latest release, codenamed Lisbon, so you can check out the Lisbon release branch. And then you can launch basically Gitpod fairly easy by just, if you have an extension in your browser, you can click on and Gitpod basically starts and set up all the environment for you. Or you can just prepend gitpod.io in front of the address and basically works the same way. I also have put up the instructions that I'll be following here, so you can check them out on tinyurl.com/hello-hopper. That basically shows everything that I'll be doing here. So just for an illustration, there's the local development topology that's being set up in your Gitpod, and also locally on my computer. So we have like a set of 5 nodes, as I said. They're like interconnected to one another on the transport layer. But also payment channels are set up between the nodes on the payment layer. So, and all the nodes are funded, and there's stake on the payment channels. So basically, anyone can talk to anyone in this network, right? So let me just quickly show the demo. So if you run your Gitpod, you basically have something like this. I have a local setup here, but in Gitpod will be pretty much the same. You're gonna see that you have nodes running, 5 nodes. And as I said, because we'll be communicating with these nodes, so if you're a developer and want to use HOPR to communicate with nodes, there's several different ways how you could do that. The first way would be you could use the REST API to talk to the node and say, okay, I want to send information over to this node or send over information to the other node in the network. And the second way would be a WebSocket endpoint, which we will also show a little bit here. And most importantly, the REST API to talk to the node is well documented. We have a Swagger interface running on each node locally. So you can, if you see this link, you can put it in your browser and you get the entire API documentation. You see we have a bunch of endpoints. You could see that, for example, you could see the addresses, the open channels, you can send messages. It's also possible to try this out interactively here, and because the REST API is protected with an API token, you may put the API token here. Don't worry if you don't see letters. Everything is also in our documentation. So that's the API token. I set it up. Now I can basically interactively call, for example, the information about the addresses. Right now I'm talking to node 1 in this infrastructure. So let me just try this out. I probably put the wrong token there. So let me just put it again. So let's... Yeah, and so if I run this command right now with the correct token, you can see that there is the native address, which corresponds to the wallet of the node, and the HOPR address, which is like the transport layer address you use for sending information over. So we can actually try out some other commands. As you can see in the Swagger interface, you also have a curl command, which you could use and run in your local setup. So if I just take it and copy paste this command and run it over in my local setup, I basically get the same information I got, although in not that fancy format as I would get in Swagger. On that tiny URL /hello-hopper, I have prepared a set of different commands that we could call interactively as a developer. You could, for example, call this to show the balances on the node to see what's the status of tokens and a native currency in the node's wallet. Another important command that you could use is to show the channels that are open and towards your node and from your node. And this is going to be particularly useful for those that who will be doing bounties with us, because we have also bounties here at Denver. And one bounty is actually involving channels, like payment channels and their visualization. So be sure to check them out, check these bounties out, because I think that's one of the easiest ones here at Denver. So, and finally, what's probably the most interesting thing, you could call an API endpoint which is going to send messages over to a different node in the network. So you can see that this API endpoint has pretty simple pretty simple parameters. One of them is the actual body of the message, and the second one is the recipient of the message, that being the HOPR address for the target node. And there's also an optional argument called path, where you could really manually specify all the hops on the way towards the destination. And I said it's an optional argument. It means that if you don't specify it, HOPR will actually select a random path, which is like feasible for the message to go through. So we can try this out. If I go back to the demo commands here, I have basically a curl command which sends a message from node 1 to node 2, but it goes through the network, so there's a sequence of 3 hops before it actually reaches node 2. So let me just show it in the command window. But before I show this, I can actually connect to the other endpoint, the WebSocket endpoint of nodes 1 and node 2, so that we actually see that the message has gone through. So the one on the left is node number 1, the one on the right is node number 2. So if I just copy paste the command here, I see that node number 2 has received the message. What I can also do, I can do the opposite, right? Send message back from node, I'll be talking to node 2 and tell, hey, I want to send a message to node 1. So just copy paste it, yeah. So there's like a very simple example of how you could use your local environment. Also, what's important, we have a fairly complete documentation on how you could use the HOPR as a platform when you think like about integrating HOPR into your application to bring privacy to your communication. I recommend to see the developer section. Here we also have live demo examples, so including source code and everything. So what we can actually do, we can use our local setup, which we have, and for example, take the Boomerang app, which is a pretty simple example, but you can learn a lot from this example on how to use HOPR. So basically, you supply the WebSocket endpoint address, HTTP endpoint address, the token, the same one I specified in the Swagger. You can send message through the network all the way back to yourself. That's a very simple example, but from the source code, you could see a lot of useful stuff you could use. So I can do that right now. So when I scroll all the way up, I can see, for example, take node number 1. I take its REST API endpoint address, put it right here. I'll take the WebSocket endpoint address of node number 1, put it right here. And finally, I specify the security token, so that's still the same one. And yeah, then I can put in a message and basically send it back to myself, so I see that the message has been received. And so for that, you could have the entire source code. We also have different examples, like for example, rock, paper, scissors application, where you have like a set of 3 nodes that are basically playing the rock, paper, scissors game. So it's also including the source code. Yeah, so that's some playground you could use for trying out HOPR and developing with HOPR. As I said, we have, useful, okay, this doesn't work. Okay, I don't know what happened. It's probably because of the second display I have here. All right, so let's show you the final slide. If you're interested in HOPR, we also have open positions, so we're currently hiring, so you can check this out. We also, as I said, have bounties here at ETH Denver, so be sure to check them out. And most importantly, the documentations page, where we have all the documentations that you saw, also including all the steps I was doing here. Everything is documented on the page. And because you probably weren't able to keep up with what I did here, or maybe Gitpod hasn't even set up for you because of the connection, you could open up the video, which basically shows everything. What I presented here is shown in the same video, so you could just play through it and see how things work out. Yeah, so that's pretty much it. Thank you for your attention, and happy to take any questions.
Yep, thank you so much. We have 5